Hello everyone, hope you all are doing well. So I am back with another Leetcode Daily Challenge and it is Leetcode number 148 short list, and it is a medium level question and I also feel the same. So the question is given the head of a linked list, return the list after sorting it in ascending order. Okay. For example, you have to sort this linked list like it is 4, 2, 1, 3, and after sorting it will be 1, 2, 3, 4. Okay. And similarly, if you see this example, it will sort it to minus 1, 0, 3, 4, 5. Similarly, if this is empty, then it is again written empty, and there the constant is there can at max 5 into 10 to the power 4 elements in the list, and the node value can go from minus 10 to the power 5 to plus 10 to the power 5. Okay, so here you can do anything, like you can just take out all elements and sort it down and override their values. Okay, so it can be a brute force, and you can try any sorting algorithm. Okay, and square sorting algorithm like insertion sort or bubble sort, whatever you like. But here also given a follow-up, like if can you sort the linked list in O of n log n time and O of 1 memory. Okay, now for this question, to do this in this much time, you should know about merge sort. Okay, so I will highly recommend you to first go through the merge sort video in YouTube. Okay, so or you can read article from GFG. I will provide the link, and you can first try the merge sort. Okay, in array, then come here. Otherwise you cannot understand the whole concept here. Okay, and I am not going to explain the complete merge sort algorithm from base. Okay, I will only explain this the requirement which and the changes which we need to do in the merge sort for this question. So I will highly recommended you to go through some videos, okay, about merge sort. Now if you know merge sort, then you can think like, okay, so we will do in merge sort, it's okay. Then the memory, how the memory can be of one memory. Okay, because in merge sort we take around of n memory. So how it is possible? It is possible here because we are doing in we are performing merge sort in the linked list. Okay, so it is possible. How? I will show you in the explanation. Okay, so let's quickly go through an explanation. Let me take an example. Okay, so let me take this first example itself. It is 4, 2, and 1 and 3. Okay, so this is pointing to this is pointing to this, and this is pointing to this one, this is pointing to a null, so I may mark here x, and the head pointer will point to this 4. Okay, this is a complete linked list. Now please don't please first go through the merge sort video, understand the algorithm properly, then come back here. Okay, so I hope you all have done that and you all now know about merge sort. So let's begin with the example. So as you all know, merge sort is basically divide and conquer. Okay, algorithm, divide and conquer. Okay, now we will do the same thing. We will divide this list into half. Okay, so first of all I have to take out the mid of this element. So I will show you in the code like how I find. You can find in any way, you know how to find the middle element. Okay, so after finding the middle element, I will break it from here. This two will be this part. Okay, go this part, and this two will go to this part. Now it is 4 and 2. Now it is 1 and 3. Okay, now again we have to break it in two part from the middle. Now it is 4 and 2. Now it is 1 and 3. Okay, now we divide the array incompletely. Okay, now Now this part is as same as we apply the merge sort in a in array. Okay, merge sort in array. But from here, when we are merging it, like we are then in merge sort in array, we have to take some extra space. Okay, and go and take two pointer and iterate through all the element. Okay, but here we need not require to take it, because in linked list there is a next pointer. Okay, so you can manipulate it. You not need to uh, yeah, check if whether it is means a complete array you have to take. It is you can do it here directly. Okay, so this is the profit of a linked list. Like you can manipulate its next pointer and other stuff. Okay, or previous pointer if it is have, but in our case it is only have a next pointer. So let's merge it. So I will merge it, and uh, I will first merge these two. Okay, so after merging these two, this will be like 2 4, and after merging these two also, it is again 1 3. Okay, so it is pointing here and it is pointing here. Now I will merge these two. Then I iterate through this list and again this list using a using two pointers. Then I, after merging, I one is pointing to 2, then 2 is pointing to 3, then 3 will point to 4. Then you get a sorted list and simply return the head of this list. Okay, so this is the complete thing, and I hope you understood that merge sort for array also working like this. Okay, so let's see like how we will manipulate these pointers. Okay, let's see that part in code. Okay, so first of all, this is the function which is already given. Okay, and I just check if my list is array empty or not. If it is empty, then I just return null. Otherwise I call a divide function. Okay, which help me to divide this list. Okay, so let's see what the divide function do. I am taking an pointer to travel. Okay, and I check if my current is null and if my current next is null. If there is no element present, or there is only one element present. If there is one element present, it means it is already sorted. So we need not to divide it further. Okay, so I just simply return the current. If it is null, it is return current. If it is just one element, then it will return the one element, one or just that element. Okay, and to find the middle part means what is where is the middle. I just using the fast and slow pointer approach, where we travel the slow pointer one time and the fast pointer two time. Okay, so when the fast pointer reach the end, the slow pointer reach the half of this list. Okay, then after that I just simply take another pointer named as next car, and I pointed uh, that one to slows next. Okay, because slow at that time, slow, if for this example at that time slow will point here and the fast will point here. Okay, now slow next, and one head is this one and another head should be this one. That's why I have taken another pointer and just point it by slows. Okay, this is the slow next. Okay, and I just simply break this loop, break this link. Okay, so I have write it down that slow next is null. Now this part is a separate part, this part, and this part is separate part with a new head. What I named is next current. Okay, next car. In my code, it is next car. You can take as a next head or something like that. Okay, whatever you like. Then I again call the divide function. Okay, and for these two, this part and this part, then again they recursively divide all that element, and after that I just call the merge function and return the value which I get from the merge function. Okay, so like what the merge function do? Merge function takes again two parameter. Okay, the first and second. Like if I if here I have shown you that there is always be a two element will group together. Okay, here, then after the grouped, again these two will group. Okay, so therefore it required two pointer, and I check if my first and second both are null. Okay, if it is, then I return null. Otherwise, if my first is null, then I just return the second, because if my one list is completely empty and other one is present, then it is already sorted. Okay, because we are doing it in recursive, so it already sorted. Then if my second is not present, then I will just simply return the first. Okay, then what I do, then I check my first value is less than equal to second value. If it is, then my first next should point to my second, means that second next. So what I have done, I just take the first next equals to, then I again call the merge function, and here I move the pointer, like, look here what it is 2 4 and it is 1 3. Okay, for this example, now here one pointer and here one pointer. Now this is the smaller one, so what I'll do, I will point its next to here. Okay, and I just, and now its next will point to here, this element. Okay, means what I'm saying you, like, it is 1 and it is 2. Okay, now you are finding that this one is smaller, so what you will do, you are taking one and you are pointing to the next smallest element between this, the remaining part of this part and the remaining part of this part. Okay, so now I pass the next pointer. Okay, I pass again this function to here, like you can see that I have write it down first dot next. Okay, then it will again sort, it will again check if it is smaller and it is smaller. Now in our case, this one is smaller, so it will take 2. Okay, and now it check for this part and this part. Now it is 3 is smaller, so it will take 3. Then it will take, then only 4 is remaining, so it will take 4. Okay, so now our list look like something like this. Okay, so this case, this will be handled by this recursion code, and after that I just return my first element. Otherwise, else part, if it is greater, then I just do the opposite thing and I just return the second element. And if both the cases is not true, then I just return null. In our case, this code will never execute. Okay, because it always return from these steps. Okay, uh, so so after that, it return the pointer to the head. Okay, the head pointer, new head, to the merge function, and it return to the divide, here. Then it return it to here, and it return to our driver. Okay, so this is the complete code, and I hope if you understand that merge sort, okay, on array, if you already understood that, then this is a cakewalk for you. Otherwise, you will face some problem. Okay, so that's why I have recommended you to uh, first go through that videos. Okay, that much short video, there are plenty of video in YouTube you can go through. As I have not that video, I will create it in a future. Okay, so I hope you understood the code. Let me submit the code. Okay. mm, okay, 80 millisecond. So I hope you enjoy the video. So if you do a like, share and subscribe to the channel, and I will see you tomorrow. Till then, goodbye.